Hello guys, how are you? Well, this video series are something that I was willing to do for a long time. It's about sharing thoughts on TDD, DDD, and best practice on architecture. So today I will talk about domain-driven design and test-driven development together. These are two huge subjects. I will do my best to make it simpler. Also, all my contents are based on my GitHub projects. So I hope you enjoy my GitHub projects. You may find me on Ivan Polovit. So let's start. Let's see what's coming on. So first of all, I wanna share my thoughts on how I see the projects being designed at this moment on our industry. It's basically a story on how to shot yourself in the foot. Everything starts by designing your application based on the data model and then creating a domain model using reverse engineering to make your data model and your domain model speak the same vocabulary. Well, when you are doing this approach, you are pretending to do TDD, basically testing getters and setters. This is something that happens a lot. Well, usually when you need to run your integration tests, you need to comment out some tests because they do not always work on the test environment. Also, when we are inside this environment, we start to complain about the TDD practices, how getting doubts on the benefits of TDD. Well, at the end, you are winning about TDD, DDD, and all this fancy stuff. Well, fortunately, I wanna share something that is the domain-driven design and test-driven development working together and how it can create a better environment for developing software based on the business. So on one side, on domain-driven design, we have these tiny domain objects, these value types, exploratory programming with this. So you are trying to learn about your domain, testing different implementations. So it is one technique to get to know your domain before committing to a whole infrastructure. On the other hand, we see test-driven development with the focus on unit tests. So small functions that create specifications for your application. These frequent short cycles. So it's possible to test an implementation, get a feedback. And when TDD is applied from the beginning, you have more confidence to change because every new change has a new test that validates the intent. So it's easy to change something with the confidence of not breaking something that you already implemented. Well, I can see that both DDD and TDD intend to have this frequent rewriting of code, testing the model, having quick feedback about what you already implemented in the last moment, and to create a self-explanatory coding. So a more clear code. Well, let's see how everything is made today. So this is a customer entity, a very simple customer entity. With the characteristic of this entity is the primitive obsession. So you see the first name, last name, and other fields are just string typed. Also, this entity has the getters and setters for every property in this entity. So this primitive obsession with this leaking model and internal fields creates services that are like this. So when I wanna register a customer, I receive basically all the fields: first name, last name, person number, email, and mobile phone number. So every time I wanna deal with these fields, I need to check for the data format, data range. Also, all these services became unnecessary, big and fat because of the recurrent implementation that you need to always do. Also, services like that with this list of parameters very similar to each other, it's easy to confuse one parameter with another. Well, then we are enlightened with domain-driven design, which is not a technology, so it's for everyone, not a methodology. I don't see domain-driven design as some workflow or a process, and is more basic principles and patterns to focus the effort where it matters most. So that is simple vision about domain-driven design. Well, that previous class, customer entity, can be changed to something like this. So instead of using that string type for each property, I can use this first name, last name, person number, email, and mobile phone number as classes that enforces these small business rules. We will see now that these classes are called value objects, and they are very useful. They use to describe the entities. Well, one good thing that of the benefits of this approach is that same CFC called register customer use case, instead of receiving the arguments as strings, are now receiving the arguments as value objects with this property like first name, last name. So the first thing is you are not having this. It's harder to make. It's harder to change one parameter with another. So it's more clear what an argument do. And the simple existence of a value object by having a value object defined means that they are valid. So you don't need to validate the value objects every time because they are validated by themselves. It makes this use case, these methods like the execute, thinner and smaller because they don't need to deal with the validation again and again. Well, and then talking about domain-driven design, I can say I can see that DDD express the model with value objects, entities, and services. We are going to see these three structures right now. And some entities act as a root of aggregates. It's a kind of a specialization for entities and performs a specific role in the model. Well, for some reason, we need to set a business so we can study in the next slides. So I'm going to use the same business that I have in my GitHub repositories, which is this virtual personal account balance application. So a customer can register a new account using its basic details. Then the customer can deposit funds into existing account. Also, the customer can withdraw, and the customer cannot withdraw more than the current balance. Well, if I'm going to see this application visually in a data table or a balance sheet or transaction history application, so a customer like this customer 55578 has two accounts, so one for day-to-day history and another account for savings, and each account has a transaction history, so an initial balance, a withdrawal, a deposit. So everything can be represented in these basic structures. Well, that previous use case help us to design the model. So the first thing is to identify the nouns and the verbs. It helps us to create the vocabulary. So identify that there is a customer and there is an account. Also the customer register, also the customer deposit, or the customer withdraw from the account. So this register, deposit, and withdrawal are useful for our domain, and the customer and account are also useful. Well, visually, this is another representation of the same domain. The account, the credits and debits, and the customer in blue. These are entities, and the entities are described by the value objects. So the customer has a first name, last name, person number, mobile phone number, describing the entity. And well, I'm going to explain later, but the customer and the account here performs the aggregate hood whole. So one way to explain that is you simply do not change the debt or the value of a debt independently. You need to go into the account and check for some constraints. So the account controls the integrity or the consistency of the credits and debits because it knows the balance. In other hand, the customer aggregate hood controls the consistency of these other properties like the simple value objects. Well, and the most important thing is about the bounded contexts. These structures are only valid, they are only consistent inside these personal expenses bounded context, which represents this basic model. So one thing about domain-driven design is the moment you create this customer, there is no intent to represent a customer for all the kinds of applications that use customer. This specific customer has the intent to represent the customer that this personal expenses bounded context requires. And another important information on domain-driven design is about the ubiquitous language. The ubiquitous language is something that it's a series of concepts that are shared between developers and domain experts. So the intent of the ubiquitous language is to be create a common vocabulary that is clear for developers and domain experts. For example, the name of bounded context should be clear for developers and domain experts. The domain model terms like customer, entity, the verbs also are important. So this should be shared and created by developers and domain experts. The TDD patterns names what are entities, what are aggregate hoods, what are value objects. These are important to know. And large-scale structures like the dependence between the communication between bounded contexts is important to share between these two roles in a company. Well, it's also important to say what are not ubiquitous. So if your business is big, so there are different areas in your organization, there are business concepts and terms that your developers will not know, and they don't want to know because they need to focus on your core domain model. So these other terms are not ubiquitous if they are not represented in the model. And us developers have a lot of knowledge of technical terms and technical design, technical patterns that the domain experts do not require it to know, right? So let's see. Well, there is a pattern called entity in domain-driven design. It is the most popular. It is simple. I can represent by the customer, account, credits, and debits. They have a unique identity. So they have a unique ID. They are mutable or not, and they refer other entities by their IDs. So this is the basics of an entity. I think everyone have developed something that are using entities. And aggregate hoods are a kind of an entity. But this aggregate hoods controls the consistency inside the aggregate boundary. And one intent of the aggregate hoods, or one constraint, is to create aggregates that are small, because it's hard to keep consistency of larger clusters of entities. So aggregate hoods are a cluster of entities, but this cluster is small. Well, the way I see an aggregate hood is an entity plus the repository behavior. It's very closely what is an aggregate. So if I go back to that example of the debit and credit, I do not expect that the credit and debit to be changed or updated independently. So it depends to be validated by the account balance at least. So the account balance or the account are the entity responsible for keeping the cluster consistent. So that specific entity receives the tag of an aggregate hood. Well, by following this practice, you may be tempted to say that every entity in your model are an aggregate hood, because if you tag all your entities are aggregate hoods, you are free to make updates freely, right? Well, but this is a code smell. It is a sign that you are not using all your effort to create a model. Well, a simple analogy of what isn't an aggregate hood is this. So when you don't see the boundaries of your cluster, so in the same case, these grapes, it's a bunch of grapes, but you do not see where it ends. It's a lot of grapes here, right? And this graph of objects starting with an aggregate hood that is connected to all your model, this isn't an aggregate hood. This is a poor design and aggregate hood. So do not follow this idea. In fact, I see an aggregate hood as a bunch of grapes like this, but it's possible to see where it begins and where it ends. So this is something that I like. If you know my projects on GitHub, like check out the manga, I follow this idea of aggregate hoods. So here I have an account with ID, customer ID, a list of transactions, and let's see what are important here. First, an aggregate hood is an entity. So by being an entity, it requires an ID, also requires to implement the iEntity interface, right? In the constructor, I usually require the mandatory fields. So it's not possible to create an account without a customer ID. So I ask the customer ID in the constructor. That's the basic of my aggregate hoods. And all aggregate hoods implement some kind of behaviors to change the state. So you don't have access to the internal feeds of the aggregates directly to make a change. You need to access the methods or the API that the aggregate hood expose. And by using these methods, you change the behavior. And well, you see in the future that the moment that you make your aggregate hood like close it for modification, well encapsulated with these private sets, it is harder to restore the state. And for that, and to work around that, you need to expose a factory method. So this load from details is a restored state. We are going to see more on that in the future. Well, about value objects, the first thing that is necessary to know is that they are immutable. So they have no explicit identity. They are unique by the comparison of the internal attributes. They are used to describe, measure, or quantify the entity. So in this example that we are studying here, the person number, first name, description, mobile phone number are used to describe an entity. Well, and I want to share something interesting here. So it's about how we see the .NET Core, .NET Standard, or .NET Full Framework in our bounded context. Well, let's see a simple example. Let's suppose that I have this personal expenses bounded context, and by using a value object called mobile phone number with an internal property pointing to a string type in the .NET bounded context, let's see what are the benefits of doing that. First, all these methods that are exposed by the string type, like clone, compare, copy, normalize, that are not clear for our business, are hidden from the personal expenses bounded context, right? So by being hidden, I mean they are encapsulated by the mobile phone number. I don't wanna know these methods. Instead, usually the mobile phone number, I have the get area code, get last 4 digits. This may be useful when dealing with a mobile phone number. So the value object encapsulates all these internal complexities and exposes what the business are interested. Well, comparing two approaches, when I develop my bounded context without value objects and using the .NET framework as a base code, I am bringing out the complexity of string, collection, reflection, other APIs into my personal expenses bounded context. So my bounded context, which has the intent of personal expenses, are huge because I bring a lot of stuff that I don't want to know about. Well, when you go to value objects, it's interesting because you have only the phone number. So your personal expenses bounded context only see a phone number with the basic methods to get specific information or to validate something. And this value object points to the specific class exposed by the .NET bounded context. Well, let's see the basics of a value object. First, all the constraints to create a value object, in that case is a person number, are made in the constructor. So it's not possible to create a person number that are not valid. So in the moment of the creation of the person number, I am going to validate all the internal fields. Well, another thing about value objects that are not exposed exactly here is that they are unique by the comparison of the internal fields. So a person number with a specific text if this text is the same as another person number with the same text, they are basically the same value object. So they will behave with the same behavior. Well, and something that I usually do to create a more rich domain model is by using these FirstClass Collections. This is something that was exposed in this essay on software technology and innovation from TalForks. It's an approach to encapsulate collections. So if a class that contains collections do not have any other field, and every method that affects the items in the collection are placed in this class. So let's see this example, the account and transaction. An account has any transactions, okay? So we are tempted to create a list of transactions in the account. This is the first thinking that we are going to do, right? But let's see, if I wanna get the transaction history, if I wanna get the balance of these transactions. Every time I wanna get this account balance, I have a list of transactions and I need to know this internal implementation. So I need to know the details of how to get the balance. Well, the FirstClass Collections, you move this logic of everything that need to know the list of transactions to a specific class. Let's see in the next slide how it works. So that list of transactions I encapsulate by a field in my transaction collection. And here, so my transaction collection exposes only add, like add transaction, or add a list of transactions. Also get balance, because that's the only logic that the transaction collection are required to do. And the benefit of this is by using this transaction collection class, if I want to get balance, I just need to call the get balance operation. Well, let's see now how it is being used. So here in the account, I have this transaction collection property. And in the withdraw method, I need to check if the get balance are valid. So if the balance has sufficient funds so I can withdraw the amount. So I don't need to know how to get the balance, like iterating out the credits, iterating out the debits, and summing both. So I just need to call transactions.getBalance, which is a simple property. Well, by using this approach, you are enriching your domain with this FirstClass collection. I like it. So the get balance operation belongs to this transaction collection class. Another thing that you are going to notice on my GitHub projects are I always do these private sets for my entities. It is a basic rule of making my class simple than the sum of its parts. Because if I create a class that has the same complexity of all the internal properties, why I'm creating a class if I'm not going to make things simpler? If I just want a variable that is public, well, there are other approaches to do that, but I encapsulate my fields and I try to hide all the details that I don't want to expose. And now, after have this brief introduction on DDD, we need to work with TDD, right? And that was the thing I promised you. And it's simple. The TDD will provide the workflow to interact with your domain. So the basics of the workflow are: you create a failing acceptance test for your intent, and then you create failing unit tests, then make the test pass and refactor, and you do this internal loop many times as necessary until the failing acceptance test start to pass. So the basic idea is the failing acceptance test is something more complex, has a broad validation, and the unit tests are simple rules that you can create a small specification and then create the specific code. Let's see how it goes. First, this acceptance test that I wanted to do is when I deposit, the balance should be changed in equivalent amount, and the account ID should be and the customer ID should be set as expected. So the idea here is in the range, I create some customer ID, an expected amount to deposit. In the account, I open the I open the account, then I do a deposit, and the balance should be equivalent to the expected amount. So, which is asserted in the last 3 lines. So, this is medium complexity, right? And then the next step, because you need to run this, and to run this you need the proper interfaces, like the deposit should be specified as an interface, and the other interface you also need to have explicitly created in your code. But when you run this at the first time, you expect an error, a failing situation. Well, you need to create then you need to create a simpler test, which is a unit test that will fail. So I will focus on the moment I create an account, and depositing an amount and then getting the balance, the expected amount and the balance should be equivalent. So I'm only interested in the expected amount and the balance. Well, the next step is to create the proper implementation for this method. And if I wanna just push code, I just need to do something like this. In the deposit, I set that the balance is equivalent as the amount, and in the get current balance, I return the same value. So by doing this, the previous test will work. Well, this is an approach, but in the next unit test, like when you deposit something, you are expecting that you add a transaction to your list of transactions. So this second unit test are expecting that the transaction history of or your list of transactions to be increased, right? And after running this test, it will fail, and you are required to write a more advanced code. So in the deposit, you create a credit to your transactions, and then you add this to your transactions. In the get current balance, you return the balance from the transaction collection. Well, the second unit tests are more advanced. So you have now 2 unit tests that are passing. Then you need to validate the customer ID, right? You are expecting that when I create an account, setting the customer ID, the account.customer ID to be the same, right? So we write this test, it will fail because we are not setting this field in the constructor previously, but then we add the customer ID to the constructor as a we set the customer ID from the constructor argument. Well, after this test, you have now these 3 unit tests that are passing, and by consequence that first acceptance tests are passing too. So this is the basic workflow of TDD applied to DDD. So while TDD provides the workflow of getting feedback of your specification and creating small implementations, the DDD provides you the concepts of how to represent your model. So you have a guide of implementation. Well, my opinionated DDD and TDD is basically sometimes I implement too much of the domain model by overconfidence. So I know how the domain model are supposed to be implemented. Well, but then I return it, covering it with unit tests and doing some small refactorings. This is not DDD, but it's how I work day by day. Well, this do not work always, because sometimes I forgot to create a specification, or I create a specification that are not valid, and I create a test that just do expect that validation to be in that way, and it creates a bug. So I am enforcing myself to create more tests first at the beginning, to have a more clear vision of what I'm doing. Also about TDD is, my focus is always to test the domain model. So usually when I design my software, the domain model and then the use cases are the layers or the parts of my software that have more tests, right? And the edges of the application, or the infrastructure, or the user interface do not have tests exactly in the same amount as I have in my domain model or application. So that is something that I usually do. And if the testing is hard, you need to fix your architecture first. So, or at least you need to start thinking on redesigning your architecture to be more testable. And at this time, you have the tools or the knowledge, or you have the basic concepts of you don't need to recreate your domain model based on your data model. You need to start using domain-driven design and test-driven development, and avoiding this reverse engineering from the beginning of our presentation here. Then this is a slide that I was preparing here, which is where the domain model fits in your architecture. Because let's see in the blue box, the component in blue are responsible for 3 other components. So these 3 other components depends on some API of the blue one. Also, this blue box or this blue component are stable because it does not depend on anything. Well, the red component on the right side are very unstable because it depends on 3 components, right? One thing about domain-driven design is usually your domain model, you expect that your domain model to be stable and also responsible, right? But that is not something that I see much, because everything starts with this basic idea of the application, your infrastructure, or web, your user interface depends on your domain model. So these yellow components trust that the domain model are responsible, are stable, right? And they build the infrastructure, the application, the web based on that promise? Well, then later some smart developer add a shining framework or a shining library that provides a small benefit, maybe a small productivity, in your domain model that was stable before are now unstable because it has two other dependencies or several other dependencies. And what happens next with your infrastructure, web, and application is that they now do not trust on a stable component. They now trust on an unstable component, and everything starts to be a mess. Well, so I expect that you create your domain in the most independent layer. So your entities do not know about the web or the user interface or your database. The same I need to point about your use case. You don't need to your use case do not need to know if the application is runs in a terminal or in a web application. It doesn't need to know about that. And about strategies of testing, I can share both outside in and inside out. Well, what are these? In the moment you have an architecture like this clean architecture, you may design your testing based from the controllers, like creating an acceptance test for the controllers, and then creating tests for the use cases, aggregates, and then creating the proper implementations until you reach the value objects. This is one approach of the outside in. You start by the user interface, basically, and discovering the inner layers. But, well, it's not exactly the user interface. It's some component that expose an API, like a controller. So a controller expose an interface, and you can test an interface. So this is the outer components in your architecture that expose an interface. And you create a specification for that, then you implement the minimum necessary, and then you go deeper and deeper discovering your architecture and your application. And the inside out is another approach when you are creating tests for the most inner component, like an aggregate hood. And then after creating the test specification, you create the proper implementation. After this testing and implementation step, you go to the outer layer, creating tests and the proper implementation until you reach your more external component like a controller. Well, there is no testing strategy that fits everything. Usually in the beginning of your application, like when you are discovering the domain model, I usually prefer the inside out. So I'm testing the model and discovering the main components. So I start with the inside out. Later, when I just need to add a feature to my application, I can do outside in. So from the controllers to the use case to the aggregates and then value objects. Well, A quick review of what you have seen here are the DDD patterns, entities, value objects, aggregate hoods, and services. About the ubiquitous language, just the concepts, testing strategies, some tips on application design. Well, you are more interested, I guess, on the implementation samples, right? Well, fortunately, I have a lot of implementation samples on my GitHub, so check out. So the implementation samples I provide to you on my GitHub. So fork me on GitHub, give it a star, and my GitHub has implementation, clean architecture, hexagonal architecture, event sourcing, a lot of cool stuff on DDD, test-driven development, and everything is another good and awesome implementation of the microservices concepts. Well, this content also are based on these books: DomainDriven Design, ThoughtWorks Ontology, Clean Architecture from Uncle Bob, and other cool stuff. So, well, what can I say now? I started today with these videos. I prepared another presentation for the next week. So subscribe to my channel to be up to date with the live streaming. Also, if you have some suggestion, just give me a message on GitHub or by email, and have fun. Check out my GitHub. Bye, guys.